All right. Hello, everyone. So today we're looking at a discrete math problem / elementary statistics as well. So you're forming a group of 3 people. You have 20 people to choose from, and you need to elect a president, a vice president, and treasurer. Okay. So that's what this 3 people group would consist of those 3 offices. How many groups can you form? Okay. So the first thing is to notice you have a certain number of elements, in this case people, and you're trying to form a size from that group. Okay, when that happens, that's what and all these objects are distinct as well, because 20 people, they're distinct. You either will use a permutation or a combination. Now the difference here is really the last asterisk there. We'll go over that in a sec, but they both have to have distinct objects if we're using combination or permutation. You're going to form groups of size R. Okay, R is less than or equal to, that's just the number of size groups that you want. That's less than or equal to the number of total people you have. Okay, but the big difference, permutation, the order does matter, and the other does not matter with a combination. So in our case here, we're going to use a permutation because the order matters. Electing president, vice president, treasurer there's an order to that, right? So just for a second, imagine you had 3 people, John, Laura, and Scott. And if I were to ask you, let's list some of the ways that these 3 people can hold office. Well, you can have John as the president, Laura as the vice president, Scott as the treasurer. You could also have Laura as the president, John as the vice president, and Scott still as the treasurer. Laura, president, Scott, vice president, and John the treasurer, and etc. And my point here is these are all valid groups here that we're considering, because the order is the order matters, right? So that's why we're using a permutation. If I was considering a combination, I would just be asking the question something along the lines of, just how many groups of 3 can I make? Okay, well, John, Laura, Scott would be one group. Okay, that's how that would work out. All right, so what we're gonna do is we're gonna use a permutation. And the way this works, I'm gonna use this notation, 20p3 is how we read that. So the 20 stands for the total number of elements, in this case, number of people we can choose from, and 3 stands for the size of the group. And what 20p3 would give you is the number of groups of size 3 you have. And the way it works is that you're gonna go ahead and take 20 factorial and divide this by 20 minus 3 factorial. So it's the total number of elements divided by factorial, number of elements factorial, divided by number of elements minus the size of the group factorial. So in this case, this would be 20 factorial over 17 factorial. Now, 20 factorial is like saying 20 times 19 times 18 times 17 times 16, etc., up all the way to 1. Right? Whenever you're told something factorial, it's the product of all those numbers starting from that number all the way down to 1. Okay, so it would be all of this, 16, blah, blah, blah. And by all means, you can use a calculator for this. But I'm trying to show you a computational trick here as well, not just how to compute this. This part right here where I have 17, 16 times 1, that's 17 factorial. Yeah, so I can rewrite that 20 factorial as 20 times 18. And I'm sorry, I just realized I forgot 19 here. Sorry about that. 20, 19, 18. So my apologies about that. Times 17 factorial, all over 17 factorial. And the reason we do that is so we can cancel things out with the factorials out easier here. That's why we did that. So then our result would be 20 times 19 times 18. And if we went ahead and put this into our calculator, we would get 6,840. So there are 6,840 groups of 3 that you can make from 20 people, okay? All right, well, thank you very much for your time, and I hope this helps. Thank you.